Hi everyone. So in this video we will have a clear look on how this analog read is functioning in Arduino, or we can say how this analog input process is happening in Arduino, and how these 5 voltage is divided into 1024 units and whatever it is. So in the last video we talked about it actually. So some people may find it difficult, so I made this video so that you can understand what actually happens. So I said you that 5 voltage is broken into 1024 units in the last video. So what actually happens is, let's say that let's have a look on this area, right, that I am zooming in. So what we have is, you can see we have 1024 small units, right? So the one unit that I can show you something written as 1 unit, right? So that means one space. So the 1 unit like that there are 1024 units, right? So from this bottom part and to the top we have let's say we have some scale that is divided by 1024 units, and it starts from 0, so the maximum value is 1023. If it starts from 1, the maximum value will be 1024. Okay, since this is 1024 units and it starts from 0, the maximum value will be 1023. So that's simple, because from 0 to 1 it itself is a 1 unit. Okay, so that is okay. So now why Arduino use this unit scaling is, we normally what we normally do is we work with sensors or whatever that is working in 0 to 5 voltage range. Okay, so what we normally do is we have when it comes to an analog input or analog read or whatever it is, we have we take the voltage as an input actually, right? So that voltage can be 0 voltage, 1 voltage, 2 voltage, 3 voltage, 4 voltage, 5 voltage, or can be anything, right? But from 0 to 5 voltage. So if you consider about a sensor normally that used with Arduino, let's think about an analog sensor or analog temperature sensor or anything. So that has supply 5 voltage and ground as normally, okay, normally default, I mean common case, okay, and that sensor's output is normally we takes to a analog pin of Arduino. So that output from that variable value, like whatever, let's say this is a temperature sensor, from the temperature value the output of the sensor will be a particular voltage. Let's say the temperature is at its maximum, the output may be 5 voltage. If the temperature is in somewhat low, the output may be near to 0. The temperature is in the middle, the output may be 2.5 voltage. So likewise the sensors are giving output in voltages actually. Okay, so this Arduino analog pin is taking that, and we are going to create some particular analog values, okay, particular values, and we are going to represent this voltage value in that particular values. So how do we use that particular value is, here we have the diagram. That means this 0 to 5 and this 0 to 1023 is connected together, right? So this is what actually happens. So what Arduino does is, Arduino normally takes 0 to 5 voltage, that means total 5 voltage, and what Arduino will do is Arduino will break it into 1024 pieces using this scale. Okay, so you can simply think 5 voltages are broken into 1024 units, small units, equally broken, right, equally divided into 1024 units. So if you come here, we can see 1024 units means 5 voltage. So what is the voltage value of 1 unit? You can divide 5 by 1024, then you will see 1 unit will imply 0.00488 voltage. Okay, so now you can understand, right? So 1 unit is 0.00488 units, and there are 1024 units. That means 0 to 5 voltage, up to 5 voltage we can cover, right? So since there is 0 voltage is also possible, we start from 0, so maximum will be 1023. So when it comes to 1023, you have to add 1 plus 1, that means because it starts from 0, and you can think it as 1024 units. Okay, so now I think it is easy. Now you have understood the concept, right? So 5 voltage we divide into equal 1024 units. Okay, so 1 unit value we can find here. So 1 unit value will be this amount of particular voltage. Okay, so that is acceptable. So, and another thing is, when we are taking an analog input value, that means a particular voltage, because voltage is analog, right? Because it doesn't have to be only 2 values, minimum and maximum. It can be 1 voltage, 2 voltage, 3 voltage, 4 voltage, 3.5, 1.2, anything, right? So it's an analog input, right? So what actually happens is, when Arduino takes an analog input from a particular pin, let's say you take this 5 voltage and connect to a particular pin, and that analog pin, when you are reading the analog value, that will be using this dividing mechanism. Okay, so what it does is it doesn't so when you read that pin, okay, so because you are getting an input from a sensor, or a 5 voltage input, or 0 voltage, 2.5 voltage, it can be any voltage, right? So when you analog read it, what that Arduino does is it doesn't give you that display the voltage value. It doesn't. It changes, it finds the particular unit value for this voltage. Okay, so it will think, okay, for this amount of particular voltage that I am getting, this is the unit value I am having. Okay, or we can say that voltage is divided by this 0.0004888 voltage, and particular number of units for that respective voltage will be displayed to you. Or you can think, if let's say the voltage is coming to the particular pin, then and then the particular voltage value is compared with these unit numbers, and the respective unit number will be displayed to you as the value, analog value. Okay, when you are saying analog read, this is what happens. So if somebody is giving 5 voltage to that particular pin, so we will see what is the respective unit value for the 5 voltage. So for 5 voltage, we can see all the 1024 units will be used, because we are dividing the 5 voltage into 1024 units, right? So if 5 voltage it comes, that means what? 1024 units are used. Or we can say the total number of units are 1024. That means 0 to 1023. So the value will be 1023 for 5 voltage. Okay. So if the 0 voltage comes, we know the value will be 0. So if the, let's say if the 2.5 voltage is coming as an input, we know we have 1024 units, and 5 voltage will be divided into 1024 units. So then 2.5 voltage means that is half of 5 voltage, right? So what is the half value of 1024? 512. So 2.5 voltage will be what do you call representing 512 units, 512 units. That means the total 2.5 voltage will be included, can be included into 512 units, because 5 voltage will be included into 1024 volt units. 2.5 will be included into 512 units, half, right? So in that way we can get the values actually. So if you give 2.5 voltage, it will be 512 units. So 512 means, since it starts from 0, 511, that means minus 1, 511 will be the analog value that will be printed in the display. So I think this is basic mathematics, and you can understand this. So we also know 1 unit value as well, right? So if you since you know this is 1 unit value, as I explained, so if you have like 512 units, so 511 units, 11 as the value, so 511 as the value, if you get the 511 value, and you know it start from 0, so then you know we have 512 units as the analog input. Then if you multiply that 512 into this 0.0000488, that means 1 unit voltage value, then you will get 2.5 voltage as your voltage output. So if you know the concept, then you can simply analog read the value and get the unit number, and if you multiply the unit number by the 1 unit value, voltage value, then you can even know what is the voltage coming from that from the sensor or something to the analog pin. So using Arduino, you can even measure the voltage that is somewhere between 0 to 5 voltage. Okay, so I think you can understand this. So actually this is what happens when we are saying analog read this whatever the voltage that is coming, and that is compared with this unit, and because this 1 unit value we know, so this total unit is 5 voltage, so whatever the particular voltage coming, that will be divided or compared, and the respective unit numbers will be passed displayed in the system. So that is what we call analog read value. So we don't get the direct values, we are getting these unit values actually. So for 2.5 voltage it will be 512 unit, and the 511 will be printed. Okay, then you should be able to understand the voltage value if you know the mathematical operation. So apart from that, I wanted to explain you how the digital and analog signals will be. So you can have a look in digital signals. We will have zeros and ones, right? 0 voltage and 5 voltage only, because there is no other possibilities there. Because when it comes to an LED, we either on it or off it, right? We either have zeros or 1, we either have 0 voltage or 5 voltage. We don't have a choice. So when it comes to analog values, we can have any number of values. So here we have 5 and zeros only. Here you can have in the intermediate values also. See, 1.5 is there, 1 is there, 2.5 is there, 3.2 is there. So wherever you touch in the graph, you can find some intermediate values. So that is what I said. When it comes to analog, from in between 0 to 5 voltage, you can have any number of voltage you want. It can be any voltage. But if you consider it as a digital input, it can be either 0 voltage or 5 voltage. It can be either 0 or 1. It can be either on or off. So I think you can compare it and you can get some idea, right? So this is how we get this analog read value. So when you are saying analog read, you are getting the unit numbers. You should remember this. So if you want to make that unit numbers to make some sense, then you should know that equation for that, right? For voltage or temperature or something, then you have to do the particular mathematical operation with the unit numbers, with the values that you already know or you found out, and then you can get the real values like voltage or something. So I think this is very clear to you. So if you want, I can show you the coding for this particular thing. I think I can do this now as well. So I will open the Arduino IDE. So I will increase the brightness. Now it's in the maximum. So what I will do is I will write void setup. So I will do it very fast, because since we did in the last video as well, so I'm kind of repeating it. And I will have this void loop. And we all know void setup will run one time and void loop will run repeatedly. So inside the void setup, I already said you, if you want to say whether the pin is a particular pin is an output or input pin, we have to mention that thing inside void setup, because if we say it only one time, that's enough. It is an output pin. Please remember this. Arduino will remember it. One time telling is enough. But if you want to read that analog value continuously, then you have to write it inside the void loop, because you have to read it forever, right? Repetitively, because the value may change at any time. So to mention this pin is this particular pin is going to be used as an output, we have some keyword called pin mode. Okay, so we already studied that. So then inside the pin mode, we have to pass the pin number. So I'm going to use pin number A0. So I'm passing that analog pin. Okay, and we have to say this as an input, because we are going to take an analog input. So first we will say this whether it is input or output. Then in the void loop we will say whether it is analog input or output. That means whether it is analog or digital. So then we will come here. I'm going to read the analog value. So to read the analog value, we have a keyword called analogRead. Okay, so then we have a bracket within the bracket, which pin you are going to read the analog value you are going to mention. So we already said we are going to use A0, right? So you have to mention A0. So I already said whenever it comes to an input or output or whatever, you have to mention two things. One is whether it is input or output, and the other thing is whether it is an analog one or digital one. It can be input or output, but it can be either analog or digital one. So here we say one time saying is enough, because this is something the program has to remember one time forever, right? So if you say one time, it will remember. So when it comes to reading part, we are trying to read the value. So with the reading only, we say whether it is analog or digital. So the reading should happen forever, right? Because value can change at any moment, right? Maybe once in a minute, once in a second, or forever the reading should happen. So that is why we had the reading inside the void loop. So if you don't understand those things, you can go watch my previous videos and come back. And also I said when we take that analog input values, we have to assign it to a particular variable. Then only it can be stored or used, right? So otherwise it will go in vain. When it comes to an output, you can do because it's an output, right? If you switch on an LED, it is on. But when it takes you an input, you have to store it in a particular variable. I said do that. So in the previous video also we did it actually. So I'm trying to store it in a variable, and we also know what we are going to get is the unit numbers, right? From 0 to 1023. That means one of the 1024 unit numbers we are going to get as an analog input, right? That analog read value. So that is an integer value, right? Because 1 unit, 2 unit we will get. We cannot have 1.5 unit here, right? Because only 1024 full units are there. So it is an integer value. So what I will do is I will declare an integer value here and name it as x. Okay. And what I will do is I will assign this analog read value to integer value x here. So is that simple actually, right? So then what is the point that whatever the analog read value will be stored in the integer value x. Okay. So how you can see that is you have to serial print the value. So to serial print, you have to start the serial communication. So that is called serial begin. So one time only we start. So we write it inside the void setup loop. So these things we studied in the previous video. So if you don't understand, just go and watch that video and come back regarding the serial begin or something. So once you read the value, then we have to print that value, right? So why do you write inside the void loop is we have to continuously print that value, right? Not only one time, but serial starting is one time is enough. So that is why it is that begin part is in the void setup. So now I am continuously print the value. So the keyword for that is serial println. Then I have to pass the x inside the serial println. Then we are done. So now if you give an particular analog input, and even if you change that analog input to the A0, okay, to the A0, then you will see the serial println values will be changing, that unit numbers will be changing. And if you know that voltage thing, if you know that equation, so what you can simply do is you can say, I'm just saying it anywhere you want, you can say, okay, I'm going to calculate the voltage that is coming. So like you can say int v, and now you know the particular analog voltage, analog unit values, right? So you can say v is equal to, the unit value is now x, right? So x into I'm sorry, it's my mistake. So v is equal to x into, so one unit value we know, right? 0.0048, I guess, 0.00488. Yes or no? So one unit is 0.0488. Now we are getting 4 x units. So the total voltage will be x into 0.0000488. So then you can also, along with this x, you can also print the voltage value if you want. Calculated voltage value from that analog input unit values, right? So you can see a print the V also. So now you have a simple program that can read that voltage value from any device that gives an output, gives some output from 0 to 5 voltage. Or you can say we have a voltage meter that can measure from 0 to 5 voltage. So if you give 2.5 voltage, you can, it will show you that as the V. Okay, because we will get that analog unit values, and we know one unit value is 0.00488 from our knowledge. And now we can even print that analog value, and also we can print the respective voltage value for that, because we multiply x by that voltage value. So I hope this is very clear and understandable. If you don't understand that, just rewatch this particular video with pauses, right? Until you understand it, pause it and understand, and move to the continue with the video, right? So I will catch up in the next video. Until then, consider subscribing us, and thanks. Have a great day ahead. Bye.